This video is going to show you how to do the dot diagram for covalently bonded molecules, which are going to be different from the ionic ones that we did in the last video, because in this case they're going to be sharing electrons instead of transferring them. So the first thing you want to do is to draw the dots, the valence electrons for each element. So hopefully you have a periodic table ready that has the valence electrons labeled, and if you follow the three rules that I'm going to show you right now, you'll be able to draw all of these pictures. The first rule is that you always want to put the first dot between the two elements. So they're going to share these valence electrons, so you want to put them in the middle. So for example, hydrogen only has one valence electron, and so even though you're going to picture each element like a square where you have a top, bottom, left, and a right, we're going to put it on the right side because you want it to be between the chlorine and the hydrogen. Chlorine has 7 valence electrons, so like I said, the first rule is that you're going to put the first dot between the two elements. The second rule is that you want to spread the dots out as much as possible. So put one on each side of the square before you come back for seconds. And then if you have more than 4 dots to put on there, you can come back for seconds, but this is the third rule. Do not come back for seconds in the middle, because that middle dot is going to be paired with the dot from hydrogen, and you can't have more than 2 electrons paired up. So we have 7 dots to place for chlorine, and we've only done 4, so I'm going to pair one up here. Compare one on the right and one on the bottom. And now what we're going to do is to share these 2 electrons, valence electrons. So chlorine has now 6 electrons that belong, valence electrons that belong only to it, plus it has the 2 that it's sharing with hydrogen, which makes a total of 8, which is stable. That's the octet rule for chlorine. Hydrogen has 2 valence electrons that it's sharing with chlorine, and that's actually okay. Hydrogen is an exception to the rule. Hydrogen and helium only need 2 valence electrons to be stable. So now what we're going to do is to draw this with a line connecting these 2. And this line right here represents 2 electrons being shared. So it's not actually like a stick between the atoms. A lot of students have this image in their head, and it's okay to visualize it like that, but just recognize that it's actually 2 electrons of negative charge being shared between them. All right, let's do another one. This one is chlorine bonded to itself. So we talked about that chlorine is a diatomic molecule, which means it's going to bond to itself and become Cl2. And in our last one, we said chlorine had 7 valence electrons. So again, the first rule is to put the first dot in the middle, spread them out as much as possible, and then come back for seconds, but not in the middle. Same thing for the other chlorine. First dot goes in the middle, spread them out as much as possible, come back for seconds, but not in the middle. And now we're going to pair up these 2 right here. It is important that you leave these dots on there. Don't get lazy with these dots, because you're going to learn in our next lesson that sometimes those dots affect the shape of the molecule. So you don't want to get too lazy and leave those off. All right, let's do another one. Hydrogen has 1 valence electron. So again, the rule is to put it in the middle. This hydrogen has 1 and selenium has 6. So we're going to give 1 to each hydrogen. And then we need top and bottom to spread out. And then we have 2 more to add for selenium, but we can't put them with the hydrogens because they're already paired up. So we can put 1 here and 1 here. And if you want, instead of redrawing the picture, you can actually just connect these dots. And now you can see that each hydrogen has 2 that it's sharing with selenium, plus it has the 4, or selenium has the 4 on the 2 on the top and the 2 on the bottom for 4 more. So selenium has 8 in this picture, and each hydrogen has 2, and so everybody is stable. All right, and 1 more of these. We have hydrogen again is 1. Nitrogen is 5. So we're going to give 1 to each hydrogen, spread it out, and then we need 1 more dot, and the only place we can put it is on top, because again, when you come back for seconds, don't put it between 2 elements. So we can pair this one up, and this one, and this one. And now notice that each hydrogen has 2 that it's sharing, and then nitrogen has 2, 4, 6 that it's sharing, plus 2 more on top is 8, and so everybody's stable. However, it's not going to be quite as simple as these pictures, because sometimes the electrons don't work out perfectly. So let me do one of these. We talked about the fact that oxygen is also diatomic, so we write oxygen as O2 if it's by itself. So first of all, oxygen has 6 valence electrons, so we're going to put 1 in the middle, spread them out as much as possible, come back for seconds, but not in the middle. Put it in the middle, spread them out, come back for seconds, but not in the middle. And now we can pair these two up together. And now your last step, if you think you're finished with your picture, your last step is to check to see that everybody has what they need in terms of electrons. So like in the last picture, we said nitrogen had 8, each hydrogen has 2, so everybody was stable. But if you look at these oxygens, they each have 5 dots on them, plus the 2 that they're sharing in the middle, that's 7, and that's not okay. They need to each have 8. And so the last thing you need to do when you finish drawing a picture is to scan your picture and look for dots that do not have partners. So these two are kind of paired up here, these two are paired up, these two are paired up, these two are paired up, the two in the middle are paired up, but notice that there are 2 that don't have partners. So what you're going to do is to take those off the individual atoms and you're going to put them in the middle. And they're going to share those 2 electrons as well. So this molecule has a total of 4 electrons that are being shared. This is called a double bond. And the way you know to do a double bond is if you don't have quite enough electrons to give everybody what they need the first time. Let's do another one of those. So oxygen has 6, so we'll go 1, 2, 3, 4, 5, 6. This oxygen is also 6. And carbon is 4. We can pair this up and this up. And now I see a whole lot of dots that don't have partners. There's this one, there's this one, and this one. None of those have a partner. So that means we're not quite finished with our picture yet. So now we need to find elements or find other dots that they can pair up with. However, I see quite a few mistakes. So let me just show you some things that you cannot do. You cannot pair this oxygen to this oxygen. That's too far. They have to be right next to each other. You also cannot pair one dot with 2 different other dots. You cannot do this and connect all of those. So what we can do is to connect these 2, and we can connect these 2. And it's okay if you want to draw your picture like this. I can see what you did, but just keep in mind that in real life, scientists always make the bonds parallel lines. So this is what carbon dioxide looks like in real life. All right, 2 more. The next one is nitrogen. It has 5 valence electrons. So first one in the middle, spread them out and come back for seconds. We're going to pair these up, and now I still see a lot of other electrons not paired. So it looks like these 2 are not paired, and these 2 are not paired. And when we do all of those, notice that there are 6 electrons being shared. That's called a triple bond. Plus, each nitrogen has 2 more that belong only to it. So that makes a total of 8. And this last one, I just wanted to show you how to draw some of these more complicated ones. Whenever you see carbon, I want you to think C for center. So what you're going to do is put carbon in the middle and then spread everything else around carbon to make it as symmetrical as you can. So we have 2 hydrogens and 2 bromines. So let's put hydrogens on the sides and bromines like this. And then we can go ahead and do our dots. Hydrogen is 1, carbon is 4, and each bromine is 7. And this one should work out perfectly. We don't need any double or triple bonds. I don't see any dots that are not paired up. And each bromine has 6 dots that belong only to it, plus 2 that it's sharing with carbon, which is 8. Carbon has 8 that it's sharing, and each hydrogen has 2, which is all it needs. So this one is stable as well. And you're going to be drawing a lot of these pictures for your progress check, so hopefully that video helped.